So for the lecture videos, we went over like 5 pretty beefy videos over the Google CoLab. So one of the first steps we did at the start of every video was make sure that our Google Drive is mounted with our Google account, so then we can go through all of our Google Drive stuff. And then this is all just importing the databases or the files we'd use. So we use the confusion matrix pretty print later on for the last step. Then we also use the iris data set throughout the entire lecture or lectures. Here are just the number of imports we use throughout the lecture. We mostly use pandas, then we soon use NumPy for like specific math functions, or to just one of the main functions I remember we're using was to make sure that the data that was originally in arrays were put into just originally inside 2D arrays were moved into 1D arrays, so we can easily read through it and also put it into more math. Just more specific math functions. This is just for displays. This is for the confusion matrix. So this would have to do with the last problem again, making sure that we're able to do our math with that 3x3 array that I will show later on in the video. And then this is just using a different function specific to how some of the scoring is done for the data sets. And then again, just more imports for certain things, importing the above confusion matrix file. So right here, we're just reading in the data set. We're reading in from the CSV file to make the data frame, so we can then manipulate it as we go on. So the first few lines of code we do are just examples of getting familiar with the data frames. So right here, it's just making sure we know that using .describe will show us certain attributes that the data set has. So right here, we can see that there are 150 rows, the mean score between all of them, the standard deviation between each of these specific columns, the minimum value, the percentiles within, and the max. And then here is just to display the unique columns themselves, or actually it's the unique flower petals or flowers, I believe it's flowers, inside of the class, which in this case the class would specify the different types of flowers. So these are the 3 main flowers. And right here, we grab the unique flowers from the above line of code. You can see we do that right here and right here. And it is to make sure that we turn these values, since they are strings, it's not something that our math functions later on can really comprehend. So we switch it over into numbers, so it can flow easier with our equations and whatnot. Right here, we start randomizing our data to make sure it's not just it's not just ordered. We have randomized data to make sure that when we're pulling information from it, it remains consistent. So right now we just randomized the entire set actually right here. So every time you run this, the set becomes ordered in a different fashion. The columns remain the same order, it's just the rows that they appear in will be different. So once you run this, actually you can see that this is now number 6 instead of the first original value, and if you run it again and open it, it's switched up a bit. So now it's number 5. And this gets rid of the index to make sure that it's not just included here. It would just take it out since it's going to be out of order anyway. So right here where you're getting the get features from the data frame, so we start to copy certain values from whatever data frame is being inputted. In this case, it would be the data frame concerning the iris. And we copy it over to another data frame. And through there, we do our math through it to make sure our original data set is not tampered with. We create a copy and then do all of our math and whatever we need to do to that one. See right here, we have the copy here just to make sure that our input data set is not messed with. And then we return the new altered data set. So then once you run this, you will end up having two different data sets that each focus on different things from the above data. So right here we're getting the length of one call. We're getting the length, and then we're multiplying it with the width to get the area of one of the flowers' petals. And then this one right here follows the same idea. Copy the labels from the data set, and then return that back to it. So now you just have a data set of only the labels, so of the specific different types of flowers. So now as we go through here, we start doing different types of, we start creating more and more types of data sets. So this is just getting like the percentage of what we're going to use for our training for our machine learning down the line. And this is the validation and the number of folds we do. So as this was explained in the video, it's as if you have, like, let's say 20 data points that you want to look at. Well, instead of looking at all of them at once, you grab the number of folds, so the first 5, and then you do your whatever data manipulation with that one, and then you get the next set of 5, and then do the same sort of math, and the next set of 5, same sort of math, and so on. So then you end up getting comparable values that should, once they're all also again randomized, you compare all these values together, and then you get you can test your data this way to see if it's consistent throughout. And then this is just doing more of what I just explained, so getting the training examples using this value right here, and then getting the validation examples using this value up here. So the training will get the BU with the 0.8, and then the percent validation we use with the, what we subtracted from that, so 0.2. And right here we get to, I'm just running and we get no output really. And then if you, right here, you're starting to see how those values are coming out to be. So we get the validation features of the summary. Again, this is using the 0.2. And then you can see how the table here is comparable to the features because they're using the same sorts of data. It's just how the sets are randomized is what's really being tested to see its accuracy. And then right here is the labels. Again, with same comparable values. So over here is when we get into more obscure stuff. So here we start training, we start normalizing our data, making sure we start applying it to different sorts of deviations for our maths. So right here you can start seeing how they differ. So this is for using our different models. So we have the model names and then what machine learning models we'll be using. The models will be inputted into into a list, and then the model predictions we put into a separate list, and so on. So first we train the data, which means we just fit the models as described above. So the logistic regression is used right here from the linear. See right there, logistic regression. We import it. We essentially just plug in this data, or plug in certain attributes to this function to make sure we get the results we're looking for, which is essentially just using this model, and then whatever data comes out we will end up viewing in a bit. And then the same thing for the SVM, or the support vector classifier. So this is just to be another model that we use. You can see they're both being appended to the list models, and then the results will also be correct. So what's being printed is something from the logistic regression class, and the attributes are defined within it, and then again something within the support vector classifier and the attributes within that. So once we start looking through the certain stuff within these models, the model is defined. First we look through we'll go through a for loop to go through both of those models, and we will then print out we'll then print out the values from the prediction, so in this case from the logistic regression, and then the actual results that we'll be comparing those to. And we do the same thing with the support vector. So we run that, we see, well, we got those two things. You can see that they're very accurate. If you look through these, there may be one or two that are different from each other. And now we start generating, this is when the confusion matrices come into play and they live to their name. So here we're generating the confusion matrices. We call the function that was imported earlier from this file, the pretty print, and then we set that equal to a specific variable. This we're just passing in certain certain functions to make sure that it gets all of the attributes it needs. And then below is when we start printing out the values. We're just like comparing the results for the training, and then testing it, and then comparing it to the overall score. And we'll do that for both the models and then again for the confusion matrices. And you can see that printed out below here. Yes. And then here's when we start displaying the confusion matrices. And so above here, actually, when we start using the confusion matrices, this is what we imported from the scikit-learn above here. It's here. So when we're doing the actual math itself, it is from the sklearn.metrics confusion matrices, and then we start printing it. It is with the imported Python file. So here's when we start using the imported Python file to print out this pretty confusion matrices. So it is right there. And then you put in your attributes for you want, and then you get a nice pretty print of the confusion matrices.